Now there guys, we're going to be talking about the orthographic projection of points, and we're going to be converting those points on the left hand side to our 3D planes model. And I think what's important to realize here is that we are dealing with a first angle orthographic projection. As you can see on the bottom left, we have the first angle orthographic projection symbol, and therefore on the right hand side of the page where we are doing the orthographic projection, you need to realize which views you're going to be drawing. It is also important for us to realize that two of these views are needed in order for us to get a 3D shape or a 3D representation of those three points A, B, and C. So if we want to get started, let's go ahead and recognize that this space over here is our left side view, this one here is our front view, and this one here is our top view. Remember that we have two dimensions given in our front view. It's our height and our length. To get the third dimension, which will be the width, I'd have to look at another view. The third dimension is needed so that we can actually go ahead and plot the suspended point on our 3D shape or a 3D planes model. Alright, as usual, you guys will be labeling your orthographic projection model over here, the 2D shape, and we will recognize this side here as being X, Y for our axis. This would be our X1, Y1, and we'll call this front view, left side view, and top view. Alright, now that we've recognized that there are three dimensions needed, let's go hunt those three dimensions. In our front view, I'm going to be zooming in a little bit on this side over here. On our front view over here, we have 3 points that we're going to be finding, A, B, and C, and I've highlighted the dimensions for point C in dark black over here. Alright, so the distance away from my X1, Y1 axis would be 10, and my distance or my height away from the XY axis would then be this figure over here, 6.23. I've already gone ahead and put it in for us over here. So let's see what I've actually done. Zoom in on this side over here. I'm dealing with my front view, and please remember, when I'm dealing with a front view, I've got to take all my front view dimensions from my orthographic projection and plot them over here. This first initial height, okay, is going to be that figure over there that we recognize in our orthographic projection, and we will also then go ahead with the 10 millimeters away from our X1, Y1 axes. There it is there, and I'll go ahead and I plot it. Please remember that this line over here is a 30-degree line coming down over here, and this is a vertical line because we're working with isometric shapes over here. Right, once I've plotted this point C, I'm going to do exactly the same with point B and A. So let's go and take these out. Now that I've actually dealt with them, I'm going to go highlight point A's dimensions. Okay, so I'm working with these two dimensions over here. 16.08, rather dubious dimension to be working with, yet it is existing, and 35 millimeters away from the X1, Y1 axis. Alright, let's go see if that is actually accurate on our orthographic projection. Right, so these two we've now done away with. And we have point A with exactly those two dimensions. Okay, so we are literally carrying all the information from our orthographic projection, the front view, that is across to our front view on the 3D shape. Remember, all the lines that are horizontal over here, like this one over here, will be presented as a 30-degree line on the 3D shape. Okay, let's take away those. We have now plotted point A and C. There it is there. The 30-degree line that I was talking to you about, 35 millimeters away from the X1, Y1 axis, and 16.08 away from the XY axis. Right, so now that we've plotted those, let's clean it up slightly. There we go, A and C. Let's go ahead and find the dimensions for B. I've highlighted them for you guys over there in the front view. I've got 15 millimeters away from the X1, Y1 axis, and I've got 40 millimeters high. Right, so once we've plotted those 2 points, please remember that this is a 30-degree line over here and not a horizontal line, because we're working with isometric shape over here as a 3D model. Let's see if these 2 measurements actually correspond with what we have over here in our front view. Our front view here for B, we have 15 and we have 40. Alright, so your height is accurate and your distance away from the x1, y1 is 15. Let's clean that up slightly. Okay, now that I've plotted those points on my 3D shape via dimension, I'm now going to go ahead and find the exact same point in my left side view. Okay, so let's go across to my left side view on this side over here. Please remember that when we deal with the left side view, these lines have to be orthographically correct. They are going to be projected horizontally right across to the left side view, and the only information that is given to us in our orthographic projection or the left side view of this projection is the fact that it is 35 millimeters away from the x1, y1 axis. We know the height because we've projected this line across already. So all I have to do is, on my 3D representation, go draw a 30-degree line to the other direction in my left side view and literally measure 35 millimeters away from the x1, y1 axis. So let's go do that. I move across to my left side view. There's my 30-degree line constructed. Remember, that must be in line, so it goes up to the x1, y1 axis, comes down at 30 degrees over here, and the length of this line here is typically 35 millimeters. Okay. Remember, guys, that if you are battling with this and I'm going too fast, please pause at some point, go back a step, play it again, and listen to the explanation. We're going to go find point A, this distance of 10. Remember, we haven't plotted these points yet. We're busy doing it now. So I'm going to go back to my orthographic projection. I'm going to look at this projection point here. The distance from x1 to the actual point, x1, y1 to the actual point, is 10 millimeters. Alright, when I go back to my 3D representation, all I've done is, along that height over there, I've now gone ahead and projected a line at 30 degrees, 10 millimeters away, and I've plotted A2. Right, so I'm going to clean up that one over there and move this across. So the very last point, they say to us that there is a line or a point 20 millimeters away from the x1, y1 axis. Please recognize the commonality here, guys. This x1, y1 axis is common in both this 2D shape and in the 3D shape. There it is there, x1, y1. Alright, so I'm dealing with this line over here. Alright, I now know that it is 20 millimeters. Let's quickly have a look. It says there it's 20 millimeters away. It's also in line with point C along this projected line over here. 20 millimeters into the left side view. I go to my left side view. It should be in line with my C, point C. I project a 30-degree line going down that way. And now I measure 20 millimeters away from the x1, y1 axis, and I plot my point. Right, so we have now managed to plot A, B, and C, and A2, B2, and C2. Please recognize these 3 points being on this flat surface, and these 3 points on this flat surface. These 3 points represent 3 actual suspended points in the middle of this hollow object over here. Alright, this is the left side view of those 3 suspended points, and this is the front view of the 3 suspended points. Now, the question comes in, do I really need this third view? Well, let's answer this question very quickly. How many dimensions do I have in my front view? We've recognized that this is a 2D shape, so that automatically answers the question. 2D standing for two-dimensional. Two-dimensional, or 2 dimensions that I found in my front view would be the height and my length. If I look at my left side view though, I would then have my height, but I'd also have a width, because I'm looking at that object from the left-hand side, and I'll be able to then determine the width. So these are the 3 dimensions that I'll need. Does that mean I need a third view though? No. Okay, because I've now discovered the 3 dimensions needed in order to find the necessary points. Alright, if you really want to work with accuracy though, you can, however, go find the top view, and you'll be able to simply project and find the suspended points. What I now want to do is, from the actual points on the flat surface of my front view, I want to go ahead and project lines at 30 degrees outward. That means I'm now going to go ahead and find those points that are suspended. So I'm going to go from this point over here and drag a line across this way over here. Alright, please note that construction line over there. I also want to have another construction line going at 30 degrees from our B2. So from B2 out this way, I'm going to now cause an intersection point over there. So that is on the flat surface, this is on the flat surface, but look at what actually happens here. I've brought it out from the flat surface, and I've taken this point out from the flat surface. And where this intersection point happens or occurs, I can plot a point, and that would be my actual point B, of which I've found the front view and left side view, and for that matter the top view. So I'm going to go ahead and label that point B. I'm going to make it capital B. And we're going to make it more visible. Okay, there we go. Capital B. Now I want to do exactly the same for A. I'm going to go ahead, I'm going to draw an angled line, which is my 30 degree line. And I want to take this angle outward. I want to bring it out from the wall, out into no man's land, into space. Alright, I might not have to go very far because I've recognized where A2 is. So I'm just going to simply project that line over there. And I'm going to draw another 30 degree line, turning my 30 degree set square the other direction, out this way, where it meets up with A. So please look at where this line meets this line. There's an intersection point over there, and yet again I have found my final point, or the suspended point, A. Alright, so let's label that point A over there. In a moment I'm going to be joining these points to form a lamina, and I'll take you through those steps. So let's go find point B. No, sorry, point C. I've already found point B and A. Now I need to go for point C. I also want to be drawing that at an angle of 30 degrees. From point C, look at how I'm taking that point and I'm dragging it outward into space. Alright, I want to have that as a construction line. And I want to also draw one from C2 outward. Okay, so C2 and CC from our front view give me these two lines over here. There they are there, and they intersect at that point there, which I'm also going to be putting a nice neat point onto, and I'm going to label it capital C. Right, there we go. So at this very moment we have a whole lot of points here. It's probably not making sense right now, but if you followed it very carefully it would make sense. What I'd like to do is I'd like to go and join these points. Let's follow these lines. I'm going to, for the misuse of this line, just to represent them in a different kind of line. This is not entirely correct using this kind of line, but I'm going to just draw what I see for my front view. I see that shape over there. And in my left side view of A2, B2, C2, back to A2. And I also have the top view that I can draw. Okay, but now we haven't found that top view yet. We don't need to just yet because we just needed these two views to find our hanging or suspended views. I have capital B, capital C, and capital A. Remember now what I've done is I've got points. Isn't this the case in point with every one of my drawings? Whether I'm working with isometric drawings, orthographic projection, one-point perspective, I'm always finding points. If I've found points and I join points, I'm going to form lines. When I join lines to each other, like in case in point over here, I have a lamina. And once I join lamina together, I'm going to be forming shapes. Alright, so in this case over here, I'm going to go ahead and distinguish clearly between the actual front view and left side view, and between that and the actual shape. Capital C, capital A to capital B to capital C. I've used I've used them as capitals to show you that this is the actual shape that I see. Right, so I'm going to just see, I'm going to zoom it out a little bit. There it is. And now, if I look at these two views, what I've actually done is I've unfolded this plane over here, this vertical plane, my left vertical plane, which gives me my left side view, all the way up to the top over here. And I've folded this top view, or the horizontal plane, downwards, so to give me this flat representation of these views. If I had to join each one of these lines, I'll have exactly what I see over here. So theoretically, I should be joining these points as well. Right, let's zoom in once more on this shape over here. If I look at my object from the left, I will be seeing its shadow cast on the wall on the back. Let me in fact go ahead and try this. Okay, let's see if that would work. Okay, maybe not so much. I'm going to exclude this one. Right, and also if I look from the right, I'll be able to see, well, if I look from the front view, if this is my left side view and I'm looking from the left, this would automatically be my front view. I'll be able to cast a shadow over here as well. So I'm going to just give that a solid. Alright, there we go. I hope that actually gives us a little bit more perspective of what we are doing. So please, if you need to, go back in the video, go look at how we found those dimensions on my orthographic projection, how we projected or carried that information across to the 3D shape, and how I eventually plotted A, B, C, A2, B2, and C2 on the front view and left side view, and how I then went ahead from there, projected outward from those flat surfaces to find capital A, B, and C, which is the actual suspended point that will give us our front view and left side view. Thank you very much, and I hope you guys stay tuned for more of my videos.